Hello everyone, welcome back to the tutorials again. So in previous session we have studied about the list of formulas which are very much useful while solving the problems. So I have listed out the formulas separately in consolidation. So you can go through these formulas, you can just remember these formulas, as well as I have marked few of the important note points so that you can able to understand the problems easily and solutions of the problem can be easily got. So you can see over here is first second problem we have completed. Third problem, a representative sample of layer of silty clay 5 meter thick were tested in consolidometer and following results were obtained. So representative sample of 5 meter thick clay was tested in the laboratory and following results were obtained. So initial wide ratio is 0.9. Pre-consolidation test stress, this is very important. So what is the meaning of pre-consolidation test? Pre-consolidation stress is a initial stress or stress at the beginning, stress at which we have not applied any load. So that is called as pre-consolidation stress. So pre-consolidation stress or initial stress is equal to 120 kilonewton per meter square. Full stop. Recompression index is 0.27. Estimate the consolidation settlement. Estimate the consolidation settlement. We have to find out if present average overburden stress of the layer is 70 kilonewton per meter square and increase in average stress in a layer is 80 kilonewton per meter square. So what are the things they have given? Let us find out first. So let us study the things which they have given. So first of all, they said that it is a 5 meter thick clay. Okay, so h is equal to 5 meter. Initial means sigma naught dash. Sigma naught dash is 120 kilonewton per meter square. Recompression index is 0.27, that is cc is equal to 0.27 they have given. Estimate the consolidation settlement if present average overburden stress of a layer is 70 kilonewton per meter square. So present overburden pressure is 70 kilonewton per meter square. So what is the initial stress? Initial stress was 120. Over that we are applying another 70 kilonewton per meter square as a overburden stress, as a overburden stress. So you can observe one very important thing over here is whatever the pre-consolidation stress is there, this stress is uh, before applying any type of overburden stress or before applying any type of load. So this particular stress is before application of any load. So after application of certain amount of load, there is some overburden pressure which is going to get created. So that particular overburden pressure is 70 kilonewton per meter square. So final stress is 120 plus 70, that is 190 kilonewton per meter square. Now initial wide ratio is 0.9. cc is equal to 2.27. Then again what they have given, 0.9 they have given, 0.27 they have given. Okay, so these are the things they have given. Now what we have to find out, we have to find out consolidation settlement. So for that purpose we are having the formula for consolidation settlement. We are having the formula delta H is equal to capital H into Cc divided by 1 plus E naught into sigma dash divided by sigma naught. Remember, this is sigma naught and this is sigma dash. Sigma naught is initial stress, sigma dash is final stress. So initial stress which we are having here is 120 kilonewton per meter square. Change in stress is 70, so final stress is 120 plus 70, that is 190 kilonewton per meter square. So delta H is equal to capital H into Cc divided by 1 plus E naught into log 10 to the base sigma dash divided by sigma naught dash. One very important thing which you can observe over here is, to make you confuse, increase in average stress in a layer is 80 kilonewton per meter square they have given, but it is not of any use. It is increase in average stress, it is not a final one, it is just an increase. Okay, but the final overburden pressure, present overburden pressure is final overburden pressure. So present average overburden pressure is 70, that's why we have to consider it as a 70. So not given about the drainage condition to, so we have taken it as a single drainage, so H will remain as a 5 meter only. Okay, now I have substituted all the quantities in the formula and I have got the answer in centimeters. So you can see over here, very important point is single drainage, so H is equal to 5, I am substituting. CC is equal to 0.27 they have given, I am substituting. Plus 1 plus E naught, E naught is initial void ratio, so E naught I have substituted. Log 10 to the base 120 plus 70, this should be 190, and that is final or final stresses, and sigma naught dash is initial stresses, that is divided by 120, so delta H is equal to 0.1417 centimeter. So this is the answer for delta H. Okay, so we have got it like this. Next you can see this example is from your previous year question papers, so December 2012. So a clay layer or clay soil tested in consolidometer showed a decrease in void ratio from 1.2 to 1.1. So decrease in void ratio was from 1.2 to 1.1 when pressure increased from 0.25 to 0.5 kg per centimeter square. Calculate the coefficient of compressibility, that is AV, coefficient of volume compressibility, that is MV, if coefficient of consolidation CV determined in the test for the given stress increment was 10 meter square per year. So coefficient of consolidation which was determined in the test was 10 meter square per year. So calculate the permeability in centimeter per second. Also we have to find out the permeability in second. If sample tested at site was taken from the clay layer 3.0 meter thick, determine the consolidation settlement resulting from given stress increment. So all these things we have to find out. First of all, we have to find out AV, that is coefficient of compressibility, MV, that is coefficient of volume change, or else I can call it as a coefficient of volume compressibility, and K I have to find out. K I have to find out by considering the value of CV, and similarly I have to find out SC or consolidation settlement, that is delta H or SC I have to find out. Now let us list out the data which they have given. So the data which they have given is wide ratio was decreased from 1.2 to 1.1, that is E1 is equal to E naught is equal to 1.2. E1 is equal to E naught I have marked because initial wide ratio here we have to consider it as a 1.2, final wide ratio here is 1.1, so it was decreased from 1.2 to 1.1. You know, when we increase the load, wide ratio decreases in case of consolidometer test, and even you have seen the graph also. Next is sigma. So when the pressure was increased from 0.25, that means initial pressure was 0.25 and final pressure was 0.5 kg per centimeter square. So here they have given pressure was increased from 0.25 to 0.5 kg per centimeter square. So capital H is equal to 3 meter. So capital H is 3 meter which they have given. So capital H 3 meter thick soil layer. About the drainage they have not mentioned, so we are going to consider it as a single drainage only. So we are going to keep H is equal to, we are going to keep H is equal to 3 meter itself. Now CV is equal to 10 meter square per year. So they have given. So these all the datas they have given. First of all, what we have to find out, what they asked us to find out, calculate the coefficient of compressibility, that is AV, coefficient of volume compressibility or coefficient of volume change, that is MV, K we have to find out, SC or delta H we have to find out. First of all, AV, what is the formula for AV? E1 minus E2 divided by sigma 2 dash minus sigma 1 dash. So sigma 2 dash minus sigma 1 dash. All these datas are given over here. So directly if I substitute 1.2 minus 1.1 divided by 0.5 minus 0.25, it is going to give us the answer of 0.4 centimeter square per kg. Yep, the unit is very important over here. So all the units are in centimeter, all the units are in kgf and centimeter. So directly I can write centimeter square per kgf. So h is in meter, we have not used h over here. Next one is coefficient of volume change or coefficient of volume compressibility. So mv is equal to av divided by 1 plus e naught, av divided by 1 plus e naught. So av is equal to 0.4, we have got 1 plus e naught. E naught is a initial void ratio. So 1 plus 1.2, so that is E naught, so which is going to give me 0.18 centimeter square per kgf, centimeter square per kgf. So it is going to give me the value of mv. Next, how to find out the value of k? Now it is important, value of k, I have to find out the value of k, I have to use the formula of cv. So you can see over here, cv is equal to k into k divided by mu w into mv. So mv we have already find out, mu w we know, k is the value, we need to find out cv they have given. So I can use this formula to find out the value of cv. So here you can see over. So CV is equal to 10 meter square per year they have given. So 10 into 100 square. So I just need to convert it. So 10 into 100 square divided by 100 square, I have done to convert it to centimeter square. So centimeters, to convert the meter to centimeter square, I have to multiply it with 100. As it is meter square is there, I have to multiply it with 100 square divided by 365 into 24 into 60 into 60. So this I have multiplied to convert the year into seconds. So 1 year is equal to 365 days into in 1 day 24 hours are there, in 1 hour 60 minutes are there, and similarly 60 minutes into number of seconds. So we are going to get the converted value as 3.17 into 10 to the power minus 3 centimeter square per second. Centimeter square per second is the converted value. Now k is equal to what? Cv is equal to mv. The Cv is equal to k divided by mv into mu w as our formula, but I am just rearranging that formula to find out the k. So k is equal to cv into mv into mu w. So cv is 3.17 into 10 to the power minus 3 into mv is 0.18 into mu w is 1000 into 10 to the power minus 6. This is very important. Why I have considered it as a 1000 into 10 to the power minus 6? Because I have kg per mu w is equal to 1000 kg per meter cube is the value, kg per meter cube, or else 1 gram per cc, 1 gram per cc. Now if I want to convert it to kg and centimeter cube, I have to multiply it with 100 into 10 to the power 3 at the denominator. So 100 into 10 to the power 3 at the denominator is going to give us 1000 into 10 to the power minus 6 kg per centimeter cube. That is the value for mu w. Remember, while substituting mu w, you must be very much careful over here while substituting the things. Okay. So I have substituted 1000 into 10 to the power minus 6 and got the value for k. K I have got it as 5.7 into 10 to the power minus 7 centimeter per second. Next thing which we have to find out is consolidation settlement. So how I can find out consolidation settlement? So SC is equal to MV into delta sigma dash into H naught. So this formula I can use, yeah, so that I can easily find out the consolidation settlement. So H they have given in meters, so I have to convert it to centimeters. So I just have converted it to centimeters. So MV is equal to 0.18 into minus zero point 0.5 minus 0.25 into 3 into 100. So I have converted it to centimeters. So finally SE is equal to 13.5. Answer I have got 13.5 centimeter is the consolidation settlement which is going to occur. Now similarly I can use another formula, that is H naught into delta E divided by 1 plus E naught. So same formula if I use, I am going to get the almost same answer, that is 13.6, that is uh, 13.6 centimeters. So here point is missing, so just you can adjust it. So 13.6 was the answer which we are getting. So I have tested with both the formulas. With both the formulas we are getting the same answer. So you can go through this problem. This problem is very important because almost all the things, almost all the criterias, everything is covered in this particular problem. Okay, so this unit conversion is also very important. You must be very much thorough with unit conversion. So kilonewton per meter cube, from kilonewton per meter cube I have converted to kg per centimeter cube. So you can just go through this conversion. If you are having any doubts, you can raise your queries. So we'll move further. So this is a logic based problem. So just we'll solve it. It is very simple one. Many of the competitive exams ask this type of problem, so I have picked up this problem, one of this problem from competitive exams. So you can see a normally consolidated clay layer settled by 20 mm. So settlement is 20 mm when effective stress was increased from 25 to 50 kilonewton per meter square. So effective stress was increased from 25 to 50 kilonewton per meter square. What will be its settlement when effective stress increased from 50 to 100 kilonewton per meter square? So when 25 to 50, when we increase effective stress from 25 to 50, the settlement was 20 mm. But when we increase it from 50 to 100, what is the settlement they are asking? So what they have given? They have given that settlement delta H1 is equal to 20 mm, that is 2 centimeter, when effective stress was increased from 25 to 50 kilonewton per meter square. So when effective stress was increased from 25 to 50 kilonewton per meter square. But what is delta H2 when effective stress was increased from 50 to 100 kilonewton per meter square is the thing which we need to find out. Now we are having the formula delta H1 is equal to Cc into H naught divided by 1 plus E naught into log 10 to the base sigma divided by sigma naught dash. Now here we don't have the value of Cc, even we don't have the value of E naught, and even we don't have the value of many of the quantities. But just to think, we can see I will keep this all the quantities as a one unit, that is x. Okay, and I will find out this x, and based on this x value I am going to find out the delta H2. Now you can see delta H1 is 2, delta H1 is 2 centimeter, which is equal to Cc H naught divided by 1 plus E naught log 10 to the base 50 divided by 25. So sigma naught dash is initial stress, sigma dash is final stress. So sigma naught dash is initial stress, that is going to be 25, and final stress is 50 in first case. Okay, so value for x are this particular quantity is 6.6439 I am going to get. Similarly delta H2 is equal to Cc into H naught divided by 1 plus E naught. So same quantity I am going to use over here, log 10 to the base sigma naught dash into sigma dash. So sigma naught dash in this case is 50, sigma dash is in this case is 100. So same way I have kept this value as it is. So these are all the constant. Cc for a particular type of soil will not change. Initial void ratio for a particular type of soil will remain same. So I have got the answer for delta H2 as 2 centimeters. I have got the value for delta H2 as 2 centimeters. So many of the students I have observed in the examinations, they will get confused about the substitution of these values. They will go wrong over here while calculating Cc, while calculating E naught. Just remember, there is no need to calculate all these things will remain same for same type of soil. So we just need to consider this quantity as a one unit or one any of the single quantity we have to consider, and by considering this single quantity we can calculate the delta H2. So I hope you have understood this particular problem. This problem is very much simple one. You can just go through it. You just need to apply the logic over here. So after this we'll consider the more difficult problems or more complicated problems in next session. We'll continue further things in next session. Thank you.